Welcome all for the video tutorial on machine learning, and today we'll continue with our fourth module, which is Bayesian learning. And under fourth module we'll be discussing about the seventh session, which is Bayesian belief network. We have already discussed how the probability plays the vital role in machine learning concepts. So we use algorithm for training purpose. To train a machine, we do the training through implementation of the algorithm, and in that algorithm we will be implementing many mathematical function over it, and the Bayes theorem plays a vital role, we all know. Okay, and today we'll see that what is Bayesian belief network and how do we implement that in the machine learning algorithm. Okay, the Bayesian belief network is nothing but it is only a graphical representation of different data and their relationship among the variables from the given data sets. From the given data sets we have several variables, and all those variables will have a relationship with each and every attributes they have. Okay, and we represent their relationship existing between them through the network, and in that network we implement an Bayesian theorem. That is what it is called as Bayesian belief network. Okay, and here it is not this network, it is not depending upon you, we don't have dependency on the attributes here. That is, it is conditional independent. Occurrence of one event, it's not going to affect the other event, it is conditional independent. Okay, and here this Bayesian belief network has the feature of joint probability. Okay, since it is having joint probability, here the Bayesian belief network can be derived easily. Okay, and it can be derived easily based on the condition with that of your probability of each and every attribute which is having the outcome as true. Okay, which is having the outcome as true, we will be able to represent our belief Bayesian belief network. Here Bayesian belief network will be representing a set of conditional independence over the given assertion. Okay, and we build an graph here, and each node, okay, we will be constructing each node, and each node will have an conditionally independent of it. Okay, and we construct a cyclic graph. Okay, we construct a directed cyclic graph here for the construction of Bayesian belief network. We'll see a real-time example for a Bayesian belief network. Okay, we'll see Harry. Harry is a person who is going to install an alarm system in his home for detecting the burglary. Okay, he is going to implement an alarm to detect the burglary. Okay, and that alarm will be responding for the two things. Okay, whenever there is an burglary, that alarm rings, and that alarm will even respond to the earthquake. It will be also responding to the earthquakes. Okay, these are all the two conditions where the burglary where this alarm responds. Okay, now whenever he is not there, whenever he is out of his home, okay, whenever he is at the job, he is assigning the responsibility to two person to indicate that whenever the alarm rings, he is allocating the responsibility to his friends, neighbor David and Sophia, who is going to take over the responsibility of intimating to the Harry whenever the alarm rings. Okay, and there is two scenarios for the David and Sophia where the alarm may go wrong. Okay, the intimation may be wrong. The one thing is David gets confused with the alarm call and sometime with the ringtone of his phone. Okay, so whenever a phone rings, he misunderstands that as an alarm and he intimates that to the Harry. This is one case where your input itself is wrong. Okay, the other thing is the Sophia sometimes she is interested in listening to the music, and sometimes when she is listening to the music she may miss the alarm. Okay, and now we'll be this is what the scenario is, and we will be determining the probability of the burglary alarm. We'll see what is the probability distribution we have over to detect the burglary, probability of the usage of burglary alarm. So this is we have constructed a network here. Okay, so alarm is the thing, the application of our, we are going to construct a model to depict the alarm. So what are the two scenarios related to the alarm? One thing is burglary. So whenever a burglary happens, the alarm has to ring. That is the first scenario. And the alarm also responds to the earthquake. This is the second scenario, how alarm is related to the burglary and the earthquake. Next, how this alarm is how this alarm is related to John call and Mary calls. So John and Mary has to intimate that to his friend whenever there is an alarm in the home. Okay, so your alarm is related to the John call and the Mary calls. Okay, now we'll construct an Bayesian, we will find out the probability distribution function. So what are all the events occurring in the network? We have 5 events: the burglary, which is represented by B; earthquake, which is represented by E; alarm, which is represented by A; and David making a call is represented by D; and Sophia making the call is represented by S. These are all the events occurring in the network: B, E, A, D, S. Okay, now we are supposed to find the probability distribution of all these events. What is the probability of the occurrence of all the events? Probability of DS, that is D is David call, S is Sophia call, A is alarm, B is burglary, and E is earthquake. The probability of this, when it is related, we derive the probability distribution function. So what is the probability distribution function for David making a call? So how does all other events, probability of D given S is Sophia call, alarm, burglar, and earthquake, we will be finding the probability distribution over there. Okay, similarly, we will be finding the probability distribution for all the events. For the earthquake, alarm, Sophia call, and burglary, we will be finding the probability distribution for each and every event. See, now we are constructing an Bayesian belief network with the alarm. Okay, so whenever a burglary happens, alarm goes on, and whenever you have an earthquake, the alarm goes on, and when our alarm goes, that will be reflected with David call and Sophia call. Now we'll first construct the distribution function for it. Okay, for burglar, what is the condition of occurrence whenever there is a condition of true? That is 0.002. What is the probability for false? Okay, probability for false is 0.988. And for earth, the condition for true, earthquake to occur, the probability is 0.001, and for false condition, it is 0.999. Okay, this is what the probability. Similarly, we will be finding out the probability distribution for all the factors. Okay, for alarm, when Sophia calls attempts true, when Sophia call is initiated, what is the probability of Sophia call to be true is 0.75 and false is 0.25. And again, for a false, what is the probability of Sophia making the call is 0.02, 0.98. Similarly, you will be calculating for even David call. So when you apply Bayes theorem over there and you find the joint distribution function here, the probability of B, burglar, to be true is 0.002, and this is the probability of burglary. And for the condition false, okay, when there is no burglary, the chance of burglary where the condition is false. Okay, when B is equal to false, 0.988. Okay, this is the probability condition for no burglary. And for the earthquake to be true, the probability distribution function is 0.001, and to be false it is 0.999. So this, with the network, we have derived what is the probability we have. Now for each and every features, we will be calculating the probability for true and false. Now it is for condition probability of A for burglar and the earthquake. Next, for David call, what is the probability of true and false condition? For Sophia call, what is the probability of true and false condition? We will be calculating. Finally, when you substitute in the Bayesian formula, you will be getting the output. This is how Bayesian belief network works. Okay, thank you all.